Hi, my name is Madison Rice. I'm a first-year medical student here at OSU Center for Health Sciences, and today I'm going to be walking through my poster, The Stratigraphic Position of a Dinosaur Quarry at Black Mesa, Kenton, Oklahoma. I worked on this project under Dr. Ann Weil and with PhD student Lauren Hall. Way up in the Panhandle is Black Mesa State Park. It's just absolutely gorgeous. Get out there when you can. In the 1930s, John Stovall, a paleontologist with OU, began excavating in this area, and he found lots of dinosaur fossils, including our state fossil, Saraphaganax. This project was forced to a stop when the U.S. entered World War II after Pearl Harbor, and it remained that way until 2012 when a new quarry was opened. We call it the Homestead Quarry. Both invertebrates and vertebrates have been found in this quarry. In 2020, Dean Richmond published a paper describing the stratigraphy of this area, which is a part of the Morrison Formation. However, it ended up raising some questions about how exactly the quarry fits into that stratigraphy. There was a landslide that occurred here about 2,000 years ago, and you can see it in this picture here. We wanted to know, is the quarry in its original geological position, or was it displaced by the landslide? Determining its stratigraphical position allows us to make better interpretations of the fossils that come out of this area. So how do we do that? Well, we need to expose beds and correlate them. We excavated 2 trenches by hand, one north of the quarry on the mesa, which we are calling the Mesa Trench, and one from the bottom of the landslide to the bottom of the quarry, which we are calling the Quarry Trench. It's not obvious in this picture right here, but I do want to point out that the Mesa Trench was dug in different sections due to rocks falling and covering places to dig. We recorded GPS coordinates at the top and bottom of each trench, and then measured how thick each exposed bed was using a Jacob's staff and pocket transit. We also noticed the composition of each bed, including things like grain size, color, hardness, and the appearance of fossils or sedimentary structures. Then, we took our descriptions of the beds and compared them. And that is what we have here in the middle. I do apologize for this being a little tricky to see on a computer screen, but come by our poster on February 16th and you can see these stratigraphy columns full size. I'm not going to put you to sleep by reading word for word the different types of sediment we found and where, so instead I'm going to point out some important differences to you. Firstly, in the mesa over here, the beds were almost all either siltstone, mudstone, or clay, with the exception being one small bed of sandstone just above the bottom layer. The color of all but the 2 bottom beds had at least some green in it, and no limestone was uncovered at all in the Mesa Trench. Moving on to the Quarry Trench over here, things are very different. Yes, it has siltstone, mudstone, and clay, but also much more sandstone and limestone. There was also white kaolinite present, which is a clay mineral that was not present at all in the Mesa Trench. Additionally, one of the limestone beds had ostracods in it. Here is a close-up photo of one of those ostracods. Ostracods are these cute little crustaceans that have been around for about 450 million years or so and are still living today. We found these fossils in the Quarry Trench, but not in the mesa. I have a table right here that's keeping score of everything. The Cimarron, Boise, and Kenton members are geological members that Dean Richmond described in his paper, so we're comparing our mesa and quarry exposures to these members. But to summarize, we found sandstone and variegated mudstone in both the quarry and the Mesa Trench, but kaolinite and limestone were only found in the Quarry Trench. So what does this mean? Well, the Mesa Trench and the Quarry Trench are much more different than we thought they would be. We believe because of their close proximity to each other, we would be able to correlate their beds and then know the quarry's stratigraphical position. But that's just not the case. We cannot correlate their geological beds to one another. So now we have 2 new hypotheses about exactly what is going on in this area. One, maybe the quarry was displaced in a landslide, but more than a few meters like we originally thought. Or 2, there's a fault between the mesa and the quarry, and one is displaced in space relative to the other. You may be shocked to learn that this part of Oklahoma does have a history of volcanic activity, and in fact, that's what helped form the mesas. This and tectonic uplift make faulting relatively common in this area. So while this does mean we still don't know the stratigraphic position of the quarry, these are some unexpected and interesting results. We'll have to do more work in the future to unravel exactly what is going on here. Thank you so much to the wonderful team we worked with this summer, to the Whit Newman Foundation, and to OSU-CHS. I hope to see you guys soon at OSU-CHS Research Days.